I'm Dr. Tanmoy Biswas. I welcome you all in my channel Climate and Chemistry. So today's topic of discussion is carbon dioxide into fuel conversion, which is very useful against the fight the global warming and climate change. Before going to details for MCQ, what type of hydrogen production is best to counter the climate change? 4 options are provided. Please write your answer in the comment box, and definitely at the end of the discussion I shall provide you the right answer. So if you see the contribution for greenhouse gases for global warming, carbon dioxide contributes more than 75%, and in second position obviously in methane. So, and by the way, I've already discussed a dedicated lecture on methane clathrates, which is a potential fossil fuel. You can go through that. So from this thing we understand that carbon dioxide is the main culprit, and the existing problem is looks like the fossil fuel is first burned in presence of atmospheric oxygen to produce carbon dioxide and energy, and that carbon dioxide are thrown into the atmosphere. Secondly, this carbon dioxide should be separated from the atmosphere and concentrated, because the global warming or climate change is happening because of the presence of excess CO2. I repeat, excess CO2 into the atmosphere, and the concentration of carbon dioxide in atmosphere is in ppm level, so very difficult to convert it into chemically into some other species. So concentration for this carbon dioxide is essential, and by the way, trees are very good for this process because they can absorb this ppm level carbon dioxide and convert it into useful chemicals. So that's why the best option or easiest option for global warming and climate change reduction is plant more and more trees. So okay, fine. So in the next step, this carbon dioxide will be utilized further for preparation of fuel or chemicals, and for that purpose we need renewable energy. And in this case, why renewable energy needed? Because if you look at this energy production cycle here, more than 80% energy is coming from the fossil fuel. So by CO2 emission we are producing this energy, and we are using this energy for CO2 fixation. It's not logical for industrial scale. For academic interest you can do, but industrial scale it is not possible, or it is not good. It will be useful when the energy source is like nuclear, hydroelectric or renewable. Better to say renewable sources are best for CO2 fixation into chemicals. Now question, what about the excess CO2 we have already emitted into the atmosphere? How you can deal? Because recently in COP26 meeting, all countries have told their concern, and the climate catastrophes happened throughout the world. Like you can recently see, we can see that Vancouver flat. So this thing happens, and main reason is excess CO2 into the atmosphere. So how this excess CO2 could be separated from the atmosphere? By chemical separation, and that could be done using this plant here. Air with carbon dioxide is injected into the plant, and this plant separates CO2 and relatively pure air comes out. And by the way, this is an experimental, this is a demonstration for a very small scale plant. We need large scale, and the most important thing, the electricity needed to run this plant should be from the renewable source. Right now it's relatively costly, but because through technological innovation, scalability and cheaper electricity can counter this issue, and we can efficiently separate this carbon dioxide from atmosphere. By the way, right now also we are majorly dependent on this fossil fuel, or better to say dirty fossil fuel like coal. So in near future also we shall emit huge amount of CO2. So such kind of plant will be essential, such that we can counter the bad effect of climate change by separating this CO2 efficiently. Now, so overall picture is, first atmospheric CO2 will be separated, stored in a cylinder and utilized for preparation of value-added chemical and fuel. And in this context, the best option is conversion of carbon dioxide into methanol. This is because both are C1, carbon dioxide and methanol both are having one carbon, so they could be considered as C1 feedstock. So this carbon dioxide could be converted into carbon monoxide first for this process, and for this process reduction reaction is needed, and this reduction could be done using 3 methods: photochemical, electrochemical, or combination of 2, that is photoelectrochemical. And second phase means, in first phase using 3 methods, CO2 could be converted into CO, carbon monoxide, and this carbon monoxide relatively more reactive, and it will react with hydrogen in presence of catalyst and produce methanol. By the way, I have already made a dedicated lecture on this, you may visit. Now question, along with carbon monoxide we need significant amount of hydrogen. You may consider it as stoichiometric ratio. So is the hydrogen source green? Because if the hydrogen source is associated with CO2 emission, then this process is not that much valid. And by the way, there are mainly three types of hydrogen emission you can see, means hydrogen production. One is gray hydrogen. In this case, hydrogen is produced from natural gas or coal, and by the way, in this case, carbon dioxide is directly emitted into the atmosphere and hydrogen produced. Second one is blue hydrogen, which is produced from natural gas, but the produced carbon monoxide is stored underground, and this underground storing of carbon dioxide is not directly impacting the global warming, but it has always associated with some risk, because due to some geological phenomena like earthquake and other issue, or leakage into this chamber can result in release of huge amount of CO2 into the atmosphere. So that can make the situation worse. So that's why this green hydrogen production is essential, where electricity is used to split water electrochemically and each produces hydrogen, and in this case, along with hydrogen, the byproduct is oxygen, which could be used for industry or in medical sector. So that is the best, and it is the net zero hydrogen production strategy. Now, how this CO2 reduction should be carried out? Actually, every strategy which can reduce CO2 is appreciated, but my best choice is electro reduction, because every energy sources are utilized for electricity generation, like solar electricity, wind electricity, etc. And alternate energy generation is not equal throughout the 24 hours. So the excess energy could chemically be transformed into such kind of fuel and utilized when needed. For example, if we look at the solar energy, it's available only in daytime but not in night time. So when daytime we have excess energy, we can utilize this energy to convert carbon dioxide into fuel, and in the night time, whatever fuel we have, we can burn and get the energy back. And by the way, in this case of photochemical or this electrochemical or photoelectrochemical, both, the selectivity is the main issue. We need to work on it such that we can get more selectivity. Additionally, the main problem with photochemical process is the unavailability of sunlight worldwide, because if you go to the polar region, then throughout the year we don't get almost similar intensity sunlight. So that's why electrochemical process is better, because electricity could be transported to those countries from some other countries, and that electricity they can use to produce their own fuel. So that is the best. For example, like Arctic region, their sunlight intensity throughout the year is less, and for that process, how they can get electricity? Solution for this process is one sun, one world, one grid, which is initiated by Prime Minister Mr. Modi. And you can see in this way, one country can produce electricity and transport into other country through underwater cable, and every country could get electricity throughout 24 hours. In conclusion, the creation of an artificial carbon cycle could be useful for this excess CO2 utilization. What actually previously we did, we burned fossil fuel to produce power. In the power station we produce electricity, fine, and for this process we have thrown huge amount of carbon dioxide into the atmosphere. So first of all, using non-fossil fuel based energy sources, we shall capture those carbon dioxide and enrich in such that chemical reaction could be done, and it could be converted into this fuels using those non-fossil fuel based energy sources. And whenever we need energy, we can burn this fuel, and this carbon dioxide we can store, and in other time we can again convert it into fuel. By the way, during that process, this carbon dioxide captured can also be utilized for the preparation of chemicals, and this is very interesting or important. Why? Because we have thrown a huge amount of carbon dioxide into the atmosphere, more specifically say in gigaton scale. So only fuel preparation is not enough to encounter or utilize or consume this carbon dioxide and utilize for us, and for that purpose, if we can generate huge amount of chemical out of it, then huge amount of carbon dioxide will be stored, separated safely and utilized. So that's the better option. Now, as a most intelligent siblings, we need to save our planet, Mother Nature. That's important for us. So, the answer of this MCQ, what type of hydrogen production could be best to counter the climate change? The answer is green hydrogen. Okay. By the way, what is green hydrogen? Green hydrogen, as I told some time before, it achieved through net zero emission because it is produced by electrolysis of water, and that electricity is produced from renewable sources. Okay. So, this is the end of the discussion. Thanks for watching.